Welcome back folks to my lecture for module 1 on the video series Introduction to Data Structures in C. Today we will be looking at some code snippets which will help you to understand the concepts that we have studied so far, that is C programming data structures, data types, constants, variables and input-output operations. Guys, I want you to basically have a look at this code and then I want you to do two things. First thing is a dry run, that is go through the code and guess the output. Having done so, basically open up a compiler, type the same piece of code into the compiler and see whether your guess actually matches with the output that is been got out of the compiler. If you guys have no compiler installed in your PC, no issues. You can go through this website which has been listed below, which is an online compiler. Just type the code and press the run button. If you get an error, basically you have done a typo mistake, go through the code again, retype it or correct it and see whether what output that you get. Okay guys, pause the video for now, do a dry run, type the code, verify and let's analyze this in a couple of minutes. Okay, hope that you have done so far whatever I said. Now let's look at the output that you might have actually got. If you have got this as the output, bravo. Now let's look into what has actually happened with this piece of code. The first one is the preprocessor directory, that is #include stdio.h. stdio.h stands for standard input output device. That is, you get access to functionalities of printf and scanf if you include this particular header file in the preprocessor directive part. Having done that, we go into our main function. It starts with main. The int out here defines a return type. This piece of code basically doesn't return anything, so we return 0 so as to basically fulfill this particular criteria of the return type. Mind you fellows, in C it's always better to return something instead of keeping it blank or void. That's a good programming practice as with respect to C. Having done that, let us look at the next line. The printf is basically a printf. The printf command basically prints something onto the screen. So what does it print? Backslash stands for the escape. So when I say \n, it basically inserts not n but a new line. So this is called as an escape character. So the character which follows next to backslash gets a new type of functionality. So having the C compiler having come across \n goes to a new line and starts printing from here onwards. So it prints EW_C_Q_UESTION and then it comes across another backslash and then it is \b. \b basically takes it one step back. B stands for back. So it comes back to n and types a y there. So that is the output of this line. Next it goes back to the next line and starts inferring what to do with this line. So the compiler then comes across what is known as \r. So \r basically \return. So what the compiler does is, having printed out this value EW_C_Q_ESTIOY, it goes back all the way back to E and starts printing characters from there on. So it prints G, A, N, E, S, H, V, V, H, A, T, which comes up to this line. So it prints Ganesh V but out here and then O and Y is retained as was printed in the previous line. So that is what you get when you output this code. That is Ganesh V Bhatt OY. Hope this explains what is happening in this piece of the code. Concepts that we came to know is how to use a preprocessive directive or include a header file. What is an escape character? We have learned what is \n, which is new line, \v, that is one step backwards, and \r, that is for return to the beginning of the line. So that is how you get this output. Okay, so let's go to the next piece of code. Guys, analyze this piece of code and tell me what is the output. If you are getting a wrong guess as with the compiler output, do not worry. This experience will help you to learn the compiler or the C language in a much better way. So guys, pause the video, do a dry run, type the code, get the output, compare, and let's see whether they tally. Pause the video, do this exercise, and come back to the video with the output. So probably you might have got this. So what is this? Again, include the header file in order to use the printf function. Next, a variable I is being declared and initialized to 30. So int stands for decimal or integer, sorry, not decimal. An integer variable I is being assigned an integer value 10. And then we are using a formatted output statement, that is printf. And we are associating different format specifiers with the same variable, which is I, which has an integer value of 30. So when this I gets associated with %x, which is hexadecimal, 30 gets converted to its hexadecimal equivalent, which is 1e, and that gets printed out instead of this part. Next, we have I again getting associated with %o. So %o stands for octal format specifier. So 30 gets converted to octal form, which is nothing but 36. So 30 in decimal is basically 30 in integer is basically 36 in octal. So 36 gets printed out. Again, 30 in decimal gets associated with %d, which is again a format specifier for decimal. So 30 gets printed out. And then something funny happens. I, which is again a integer variable, gets associated with %f, which is for floating point. Mind you folks, this doesn't get converted to 30.333. If we want to do this, we have to do explicit type conversion. A format specifier of %f doesn't actually convert a integer data type to a floating point data type. So probably you might have guessed this as 30.000, but as this format specifier is unable to convert, it basically prints out 0.000. So that is what happens with this piece of code. Takeaway: integer variables or integer numbers stored in a variable can be converted from integer or decimal to octal, hexadecimal, etc. But a decimal value or an integer value cannot be converted to a floating point value using just format specifiers. We have to do an explicit conversion in order to do this. That's the takeaway from this code. Okay, let's look into another piece of code. Okay guys, pause the video, do a dry run, type the input, type the code, get an output, compare, and come back to this video to look at the code and analyze it. Okay fellas, hope you are done now. So if you get an output of 3, and if the same thing basically is your guess, bravo. If not, that's okay. Let's analyze this. Again, if you look at the main functions, there are two variables declared of type integers, the variable a and b. A is being initialized to 1 and b is being initialized to store. Again, in the main block we have something which is called as these two curly braces. So this is one part of the code and this is another part. So in this section of the code, what actually happens is A gets added with B and gets reassigned to A. So A becomes 1 plus 2. So A becomes 2 and B becomes, A becomes 3, A becomes 3 and B is 2. Later on, another variable int A gets initialized in this section. So this A is different from this, mind you folks. This is a local variable in this, whereas this becomes a global variable. So another variable A gets declared and initialized to 10. Later on, again I do A is equal to A plus B. Now which is the A that I am using? Am I using this A or am I using this A? So out here, since this variable was not declared and initialized, it was this A which was getting used. Whereas in this part of the code, it is this A which gets used. So A becomes equivalent to 12. However, when you come out of this X section, the local variable does get vanishes off. So this A which was declared, initialized and later modified just vanishes off. And what remains out here is this A and B. So when you print the value of A out here, what you get is the value of A, which is 3 and not 12, as this variable gets depleted or vanished when you are in this part of the section. Okay, so that's all. Let's go to the next piece of code. Okay, go through this code, guess the output. Fine. I hope that you have done your exercise. Now let's look at this and analyze this piece of code. So output basically depends on the type of compiler that you are using or the target that you have set. By default, when you run a code, the target hardware that you have chosen is the hardware of your PC. Okay, so here what is happening out there? I am basically trying to find out how much bytes of memory do I need if I want to store this information. So that is what size of operator gives me. What is the size of memory required in order to store this information? And I am printing it out as an integer. So by default, a double is being assigned as a data type to store 6.5, not float. So 6.5 gets associated with the data type double, and in Turbo C, C++, or if you are using a GCC compiler or Visual C++, you need 8 bytes of data to store a double. So 6.5 basically gets associated with the double, and the number of memory bytes required to store a double is 8, as we know from my previous lecture. Next, how many bytes of memory is required in order to store 90,000? So this type of data gets associated with that of a long int. Why? See what is the max data that an integer can store. Go back to my previous lecture and see what is the maximum data which an integer can store or an integer variable can store. Obviously it is less than this. So what next is the option available for the compiler? It is long int. So long int is the data type which gets associated with 90,000. So what you get is 4. So 4 bytes of data or 4 bytes of memories is required to store this 90,000 data. Next, what is the size of data or memory that is required to store the data type A or a character? Again, the type of data which gets associated with the character is A. Again, it is compiler dependent. If you are using these compilers, then you get 2, and if you are using Linux GCC or Visual C++, you get 4. Okay, so that is the type of data, that is the amount of memory which is being used by the compiler to store it. Again, dear folks, this is all subjective in nature, so it depends on the compiler and the hardware that you are using, that the compiler decides to allocate memories in order to store this type of data. Okay, so let's go to the next piece of code. So go through this code, do a dry run, type the input or type the code, get the output, compare, and let's come back and analyze this. Okay guys, so hope that you have done this. Let us analyze this code piece by piece. Here I have declared a variable of type integer, and what am I doing out here? I am basically trying to input a data into this integer variable and then print the output of the scanf function. Okay, so an integer variable is been declared, the data or an input from the keyboard is scanned, it is basically stored into this integer variable. Mind you, use the ampersand function always with scanf. So you are storing the data from the keyboard into the address pointed by this variable A or X, sorry. Okay, and then what type of data? An integer data. So integer data is being scanned and it is being stored into the memory allocated for this variable X. Okay, so that's why we use ampersand. After doing that, we basically print the output of not the variable or not the data that is being stored in the variable, but we are printing the output of the function which has basically done this task. So what does scanf actually output? Remember me saying that in C it's always a better practice to return something. So by default every function in C returns something. So what does scanf return? Scanf basically returns the number of data that it has basically read. So how much data has been read into this function? It is just one data, okay, or one variable. So scanf basically returns 1, and that is what gets printed out in the output. Hope that this has cleared your doubt. So that's all for folks today. Join me on another lecture on Guess the Output. Hope that you have enjoyed it. Thank you.